And hello YouTube, welcome back to our C++ tutorial. And well, we're not exactly doing C++ now, we are actually doing makefiles. So in the last video, I've been actually experimenting behind the scenes, so let me just do some adjustments first. Okay, so this is our makefile, right? We were talking about some variables, and we see that, hey, using this makefile, the potential for these variables is very big, because when I do this list C++ file, I'm able to get all the C++ files within this directory. So how are we going to use this to make a generic makefile that's able to compile all your C++ into objects, and then all your objects into one binary file, just like what we are trying to do here. Okay, so this again, this code, it's supposed to take the main.c++ and vectors.c++, partially compile them into object files, which are O files, right? Partially convert them into object files over here, and then it will compile these two based on these dependencies, of course. It will compile these two objects into one of these binary files here. Okay, so how do we kind of automate this process? Okay, so let's start by making some variables here. That's very important to make the variables. Okay, so we can make it more generic by inserting some variables here. One of the very common variables that you kind of use is this variable called cc, which it basically stands for your compiler. So the compiler here is G++, alright? The compiler here is G++. So whenever you see this cc, it will refer to this compiler.g here. So everywhere I see G++, I can delete and I'll just put cc. Okay, let me see whether my syntax is right. Okay, oh, it has to be curly braces when I call these variables. So let's see. Let me put these. And remember, I use this colon here as a safer way of defining my variables. Okay, so let me change these things one at a time. First is this cc, and let me see how much time I have left. Okay, I have about 18-ish minutes. So let me time myself for 18 minutes so that I don't overrun too much. Okay. So anyway, I don't want to make videos too long. If not, it's very draggy, boring. It's hard to keep attention. Okay, so this is the other way. You see this cc? Okay, it will be everywhere you see this cc, you can call using this cc with this curly braces and $sign. It will just replace all your GCC, G++, sorry. So this will be your compiler. Oops, let me undo that. Let's try again. Curly braces with CC here. Alright, curly braces with CC. So I want you to get used to all of these signs here that you will see in the makefile, because when you first see them, it can be very intimidating. So I don't want you to be too intimidated by that. Start getting used to all of these signs over here. So when I have this G++ here, that will be able to change your compiler in these three places where I put this cc. So that's the usefulness of these variables here. So let me try doing the make again. So you see, if you do that, it will sort of give you this code here. Give you this code here where it says G++. It will compile main.cpp into a object file, and then the object files will be converted into the vectors file. So that's how we kind of run it. Of course, we can do a G++. I think there's a version 9. Alright, there's a version 9 of it, so we can actually test to see whether it works. If you don't have version 9, then you have to do a sudo. You have to do your sudo apt sudo apt install build essential if you're using Debian based systems, which is Ubuntu, Linux Mint, and MX Linux, etc. or even the Windows subsystem for Linux, you can have your Ubuntu version. Okay, yeah. So then if I type make here, okay, oh sorry, yes, I forgot. If I can change this CC to G++ version 9. Okay, so this is a different compiler. Okay, of course, using G++9, it will give you an error because you're supposed to use G++9 from the start. Because I use G++, which is I think version 6 or 7 based on the OpenFOAM one, and G++9 is kind of different. Okay, so let me clean everything up and let me do a make again. So you see, I can just change one variable and it will change the way this code works very significantly. Alright, so let me change back to G++. Yes, let me change back to G++ and let's see whether it works. Let me run make and it will work. I guess this is because it's backwards compatible. That means never mind, forget it. So yeah, basically it works. I'm not going to explain that now. But anyway, this is how you can use variables to really change the way you work with makefiles and start to automate compilation. So OpenFOAM has a very much more complex version of the makefile. They call it a wmake. It's a makefile on steroids. You can see how much data there is here. I'm not going to go through them because you don't really have to know how to use this particular makefile, okay, or this customized wmake executable. Yeah, this is just to give you an idea of what's going on behind the scenes, so that you're not too put off by the whole solver compilation and writing. Okay. So just know that OpenFOAM has a different sort of makefile and is way more complex than what you're seeing now. What I'm just showing now is just the basics. Alright, so okay, so let's start replacing more things. For example, I want to actually replace this main.o and main.cpp. Alright, main.o and main.cpp. Okay. So how do we do that? Okay, basically I want to get my main.o. Alright. Okay, basically I want to get the names of my C++ files and convert them into O files, object files, right? So how are we supposed to do that? Okay, so the basic idea is to start working with what we have. So I'm actually kind of following the code here, not directly, but I'm kind of using concepts being displayed there for my own, for the code you're seeing here. Okay, so first thing first, what do we have with work? What do we have now? Right, we have this srcs file using this wildcard thing. So this wildcard will actually look for any file with the C++. So this star is a wildcard, and then you have to say it's a wildcard pattern. Okay, it will look for any C++ file, right? Any C++ file. So if I echo this list C++ files, it will give us vectors.c++ and main.c++. Okay, of course I want the text over here, vectors and main. I don't really want the .c++ at the back. Okay, so how do I go about doing it? So before we actually start with the object files, we actually need to make a vectors.o and main.o. Alright, so that's how we kind of do what we need to do, right? So let's start with that. Okay, so let's start with that. Let's do our makefile, and we will use this particular line here. We can define another variables. They call it bins. Bins, I guess you can call it for binary. And what they will do is that they will take the src variables, for example, this source variables, srcs, and then it will cut out this last part, the .c, using the percentage signs. Okay, so I think that's what that is supposed to do. Alright. So if we were to apply it to this situation here, we can do it as follows. Okay, this is the bins variable. Okay, and this will be defined as, alright, I need to bracket it up. I have the source file again, the source file, sources file, and then I have a colon, and then I'll have 2 percentage signs here. What do I have within the percentage signs? Within the percentage signs is the stuff I actually want to cancel out. Oh, there's an equal sign here too. Alright, so let's cut that part out. Let's cut that part out. So I have a dot C++ equal sign. So that is the part that will be cut out using this very funny looking syntax. So basically what this bins file is doing is it will be defined as whatever is inside this source file, whatever is inside this source variable, and whatever is inside this source variables, and it will cut out the .c++ files here, or cut out the .c++ part. And again, we can just echo this part as well, just to see whether we are on the right track. Okay, so I have a bins here, and let's go. Let's go for bins. Alright. What am I doing? Okay, let's type make list C++ files. Okay, so look, this does exactly what I was saying it will do. It will cut out this C++ files so that we have the text over here, vectors and main. Alright, that's very convenient for us because now we can start making our object files using the compiler. And okay, right, let's get back to our makefile. So the idea is that now we have these variables. Let's see what we can do with it. Okay, so let's go to the makefile, and okay, there will be these variables here, the sources variable, the bins variable. So how can we use the bins variable here? Okay, so do you see the compile over here? Well, there are a few ways we can actually do this bins variable thing. Okay, there are a few ways. We can actually try this thing using bins.o, right? Okay, bins, and hopefully you kind of put a .o at the back. Hopefully this works. So let's see what happens. Okay, I'm going to type make, and then it's going to give us an error. So you see, look at what is being called here. The file that's being called is g++vectors.o -o vectors. And I'm like, hey, wait a minute. Don't we see that when we get this bin file? Okay, when I type this C++ files, doesn't that include the main.o as well? And yes, you would be right, we have a main.o as well. Unfortunately, when you put the bins file.o, as we saw earlier, okay, if we have a bins.o, then we won't have the we only have the first variable over here being called. So you only have vectors.o being called out and not main.o. So what can we do then? Okay, so one thing we can do is just to delete these o's. Okay, and then we try again, and then this I say, okay, let's see. Yeah, we try to do the makefile, and again, this file is called g++vectors.o, and then it looks for the out, and it gives us the output of vectors. Okay, so again, that's kind of problematic. So did I forget to save? Okay. Yeah. Let's try again. Okay, so yeah, the reference is kind of incomplete, right? Because okay, one thing we're doing over here is that we are doing this vectors H, and then we are looking for bins. Okay, so bins is actually going to look for the two variables. One is main.o, one is main and one is vectors. So these two bins file, one of them is called main, one of them is called vectors. So we need to make the target. All right, the target here, main and vectors. All right, so we're going to do that, and then now it works perfectly. So you see, we have g++ vectors.cpp and we have g++ main.cpp. So look at this. Once we do this, that will be fine. Okay, and one more thing, that's even more powerful. We can make it even shorter. Okay, just like one last bit. I'm not going to do all of it. I'm not going to do all the things you can do with the makefile. I'm just going to introduce you to the makefile and some of the syntax of it, so that it's less scary. Okay, yeah, less scary and more familiar, so that when we use OpenFOAM's in-house custom makefile called the wmake source code, okay, or at least when you're using this, it won't be so scary. The stuff won't be so foreign. You will roughly know what this is about. Of course, I'm not going to tell you again. I'm not going to tell the source code, but I'm just going to go through how to use this based on what is already here in this OpenFOAM in CFD Direct. I think OpenFOAM.org version. It's a foam foundation. So this actually is really good for roughly, making telling you how to make an application using the wmake file. Okay, so yeah, let's finish up with the makefile first. One thing you can do that's very nice is you can actually use a wildcard here. Okay, you can use a wildcard here. For example, if I have this bins wildcard, I can actually call this wildcard using this piece of code over here. Okay, for example, I have this percentage sign. You see this percentage sign here? This percentage sign is a wildcard that will be called whenever you use this $sign variable here. Of course, when I call vectors.h, it won't actually look for that because that's not a variable. But whenever I call a variable in one of my functions, it will look for what you can use this wildcard to substitute for the vectors there, the things over there. So for example, you have main.c++, right? You have main.c++. All right. What you can do is okay, you can basically replace it with the wildcard. So okay, bins over here, this variable represents, there are two variables here. One is main and one is vectors. I can replace both of these lines of code with this percentage sign based code. So let me show you what I mean. Okay, so I'm going to do a hashtag, so that will actually get rid of this code, make it into comments, because these comments are very much bash based. Okay, very much bash based. So I can do a percentage sign here instead. And okay, that will be my target. And then what is the prerequisites? Usually I'll have a C++ file, right? Of course, for this vectors file, I will have a vectors.h there. Right, that's a prerequisite for compiling the vectors.c++. But for now, I'll kind of just skip it first. Just want to show you what the functionality is, and we'll just stop there. Right, so I will have a percentage sign.c++. That will be the prerequisite. And then what do I want it to do? I want it to compile. So I will give it this. I'll do this compiler thing here, and now I'll give it the -c flag, and then I'll put okay, instead of percentage sign here, I won't use a percentage sign here. The sign to use here will be this dot and caret thingy, or this dollar sign and caret thingy. So that will be the way to write variables here. Now I won't go into detail why. I'll just accept it. Just accept what it is. That it's a variable that needs to be used. So I'm just gonna use it like that. All right. Now using it like that, let's see what we have it when we do make. Okay, so when we do make, the exact same code is being given out. So what is this doing? When you run this all file, it will run the compile and the hello world. Compile will actually call the bins file and the vectors.h file. These two will be the dependencies. Vectors.h is of course a file. Bins here is actually it will point to one of our targets. So bins file will actually look for this percentage sign. So this percentage sign will be what the bin file is called. So wherever you see, your bins file actually has main and vectors, right? So you will have main substituted in here. Then that's the target. Then wherever you see the percentage sign, main will be substituted again. So this will be main.c++. And then you will once you have your prerequisites main.c++, you actually run your compiler, and your compiler is actually G++, and it will give it this C flag to give you this output file. And this again is the wildcard. It's like a variable reference, so that it will take whatever is here, this percentage sign.c++, which is main.c++ in this case, and you'll put it here. Alright, then you'll do the same thing for vectors. So because we have two variables here, one is main, one is vectors, so the vectors will be substituted over here as well. Then you got vectors.c++. Then you do this compilation with -c on vectors.c++. So you got vectors.c++ being substituted in here. So this kind of shows you, just demonstrates to you how to use some variables, and based on this, you can see that makefiles are pretty powerful. There's a lot of potential you can do, a lot of scripting you can do to automate compilation. And if you want to bring it up several notches, that will be then, you see the huge makefile you see here in OpenFOAM called wmake. And I'm not going to go through any of this. I'm just going to use it, not going to edit this wmake file, because there's really no point. Just use it as it is, because it's already nicely scripted. Alright, so that will be more of the topic for the next video, but I guess we're done for now. I shall see you next time.